is designing the system. You've got a choice, usually, between pipelining and parallel processing. So parallel processing is just, well, each and every component is going to perform multiple tasks. Okay, the interest is that you don't have bottleneck, usually, that you've got in pipelining architecture. Pipelining, if there's one component that takes too much time to perform an operation, okay, you've got bottleneck. Everybody's waiting. With parallel, okay, it's far more, it's getting faster. Well, so you get less throughput, but you get also less latency and less jitter. Pipelining is just the opposite. Okay, it can go very fast as long as there's no bottleneck. Okay, you will get better throughput, but you have some problem with latency. That's normal, because each time you've got a piece of data and you forward it to the next core or the next component, then you've got an overhead just for, well, transmission, context change, etc. So in terms of latency and jitter, we'll get more. And then, of course, you've got this generic versus specific. Okay. Sometimes you would like just to say, I've got some CPUs, very generic, very easy to develop. That may be a problem. Also, if you have multiple components, it's harder to develop. Okay, but usually it's the only solution. Because if you just have one CPU, then usually slow path operations are very quickly going to flood your system. And then you got no more performances, and we see how we can bypass them. Well, just a short talking about the network processors. This is what I said. You've got different kind of architecture into these chips. They've got multi-cores. Some of them handle the slow path operations. Some of them don't, so they need an interface. It's cost in terms of time. Depends on, well, what you want. The real problem here is that, let's say you've got some network processors into your IPS, okay, and you say, I want to get good performances with, like, short packets, okay? So you say, I need a system that should be, like, in pipelining. Pipelining is very good for that. But then, in the middle of this traffic, you've got some payload. That's normal. I mean, usually, you've got some legitimate traffic with some payload, and then performances are going to go down. So as a vendor, you've got a choice, usually, to say, I'm good at for small packets, and usually for tests. I'm good at handling large packets. But then, with small packets, I will not get very good performances. So that's typically the shortcoming you've got here. And that's still a question of cost. I could say, well, I can have these two families of network processors and a system to classify the traffic, small packets, large packets, and on top of it, another system to rebuild all the data, frags, all this. Okay, but it's far too expensive, I can tell you. So usually it's going to be a simple matrix that takes into account, well, performance, marketing, and cost, and then security. So vendors are going to make a choice. They're aware of that. We've got also some very funny examples of, these choices made by the vendors. A few years ago, a network processor vendor used to sell to IPS vendors, or all these security device vendors, a chip network processor which was said to handle, 802.1q VLAN tags. So everybody said, okay, let's build our IPS on top of it, on IDS also, it was all the same. And the problem here is that it was good for IDSs because it was able to read these tags, but it was not able to rewrite them. So it means that on your IPS, could read the data, could not send it back on the right VLAN. So it's just black hole. And it's very funny to see that at this moment, like 2 years ago, many vendors had some issues with VLAN tags. There's been some, discussion, rumors about they don't handle VLAN tags, or they don't handle VLAN tags also, etc., etc. I can tell you that at least 2 or 3 vendors had the same problem because they use the same hardware, same architecture, and just made the same choice at the same moment. It's like for the bypass. Bypass switch, purpose of the game is if you've got any hardware or software issue on your IPS, then the bypass is going to be activated, and the traffic is not going to go through the IPS. This is usually what people want, because as I told you, as a CSO, first of all, just want not to lose legitimate traffic. So it's very expensive, especially for fiber ports. So usually vendors are going to rely on third-party vendors just to sell this kind of equipment. And it's very funny to see also that 2 or 3 vendors still have the same product for bypass. So I'm not going to tell you the URL, but you've got the URL of this kind of bypass switch vendor, and well, then you just add at the end of the URL the name of an IPS vendor, and you got the product. And then you add the name of another IPS vendor, but exactly the same page, just with another logo. Okay, so everybody uses the same. Okay, all the vendors are aware of that. All the vendors are working on the same basis. And well, also it's not hardware, but kind of same story. You know, bugs. Recently, you've seen this way to bypass a snort and some URL investigation. I'm just curious to know how many vendors, it's mainly for layer 7 firewalls there, I mean some IPS also, did just update a few days after that, just because they were patching something, maybe patching their snort engine, and maybe even worse, how many did not patch? Because a lot of vendors just rely on snort, so those that didn't patch are still vulnerable, and I found some. And then, of course, performances. This is, I think, the main reason why you've got limitations and why it's quite easy to bypass IPSs. You've got this, well, the need for speed. You need to go fast, very fast, okay? That's the rule of the gigabit. When you go to a customer, they said, I want a box that's going 5 gig. Okay, it doesn't really know what it needs for that, but okay. And latency is now the value, the metric, which is good for us. And sometimes even values are kind of stupid. Are you sure you can make a difference on your network when you've got like 30 microseconds of latency against 200 microseconds? Maybe for some traffic, not all of it, definitely. So you've got this throughput. That's holy grail. You've got to get best throughput as possible. Then, okay, you're a vendor, and you know that, first of all, the guy in front of you is probably not be able to test properly the IPS. And you also know that he will not buy anyway if you don't handle this bandwidth. He tells me he needs 2 gigabit, I'm going to give him a product that does handle 2 gigabit of traffic, okay? So what do I do? What are the issues? Well, interface cards, network interface cards, no. Switching fabrics, no. All the rest, yeah. You've got performance issues everywhere after that. So when you go into physical components, you've got, well, bus speed, memory access, all this is going to impact performances. In terms of software, all the features you can have, you know, like, okay, some stateful, analyze signatures, generate SYN cookies, and do some bandwidth management, and, well, behave like a honeypot, all this. No, come on, that's big use of resources. So, in a nutshell, what we want is security which is transparent. And at the end of the day, you say, I like better have no security than traffic disruption. This is the reason why you've got all those bypasses switched. So you cannot accept any kind of performance impact. So there are some trade-offs which have been made by the vendors. Some of them are visible, like this application port selection. When you say I'm going to analyze HTTP traffic, usually you've got a choice, and you're going to say HTTP traffic is going to be analyzed on port 80, port 8080, port I don't know. Sometimes it's going to be a little bit different. Okay, it's going to be like, well, like this snort possibility just to say I'm not going to search for shellcodes on port 80. Okay, so you just save resources. Okay, and sometimes it's even into signatures. We're just going to say this signature, I just look for it if it's a packet going to port 80. Same for fragmentation. And it's very funny to see that the more you go into upper layer fragmentation, the less options are visible. For layer 3 fragmentation, you've got a lot of options. Size of the frags, maximum size, number of frags, amount of time it's kept in memory, all this. Layer 4 fragmentation, which is just like having a URL in two different packets. Sometimes it's just a checkbox. Sometimes it doesn't even exist. And layer 7, nothing. I think I never saw any kind of option to play with this ERPC fragmentation. Okay? So that's problem. We see that more and more vendors are not going to just implement this kind of feature. It's too good in terms of performance, and all in all, okay, that will provide good security or some security. That should be enough. And you've got some others which are kind of less visible, like some operations that use a lot of resources, like just calculating for checksums. What for? Okay, remote systems are going to do it. So sometimes layer 3 or layer 4 checksums are not going to be calculated. So it makes it very easy to do some insertion there. Mid-flow traffic detection. Follow all those sessions and sequence numbers. That's boring. That's taking time, memory, resources. Okay, maybe I'm not going to do it. Firewall is going to do it somewhere on the infrastructure. I don't need it. Okay. Well, when you generate SYN cookies, we'll see that you have to be pretty careful. Else, your system is going to be protected against SYN floods. But it's going to be ready to be spoofed. And that's another problem. And well, so sometimes all this stuff are presented as some options hidden just to make sure customer is not going to activate them. Sometimes they don't even exist. Okay, just to make sure. I've got also this one, which is maybe the most important, that's offloading. As I told you, the problem is performance. So what's happening if I'm running out of resources? If I'm starting to lose some packets? If my resources are reaching like 80%? So usually there are some mechanisms on IPSs that are just going to forward the traffic without inspection. So there are different kind of options. Sometimes you're just going to reduce the number of signatures you're going to apply to a packet. Sometimes just going to say, okay, traffic is bypassing during maybe 10 seconds, and then I will just see if my resources are still okay. So you've got this way, and it's a pretty easy way, you know, just to bypass an IPS. It's just to, well, just stress it. And when these resources are going to reach very high utilization, usually it's going to bypass the rest of the traffic. And then, well, just launch your attack, you're not going to be detected. We see some examples there. An example of, a little bit more detailed example of trade-off you can find. SYN cookies, remember the problem? Is you've got a SYN, you receive a SYN, you're going to generate a SYN ACK, okay? You want to protect your servers. So you're going to generate a SYN ACK, but you don't want your TCP to be overloaded. So you're going to generate a sequence number in your SYN ACK, which is calculated based on some network information, like source port, destination port, and all of this. Okay, so your sequence number is just a function of these network parameters. Well, that's very easy to guess. So here, you're spoofing already. So what you're going to do is to use secret seed and use a one-way hash function so that you make sure that SYN cookie that's going to be generated cannot be pre-calculated by somebody. We cannot guess what will be the SYN cookie, well, sequence number, sorry. Okay, and then, well, you've got performance issues. Those one-way hash function, I'm sorry, but it's pretty greedy. So you would like to use some function which accept pre-calculation. And there comes MD5. MD5 is okay. But you know that we saw some collision issues and all of this. But you can say that, okay, maybe enough. And this is this kind of trade-off. Well, sometimes the trade-off is just to say, well, you don't really need this MD5 stuff and all this, just generic SYN cookie.